Okay, let's look at some more things on implicit differentiation. This next problem, it starts out by saying that we're going to find the two explicit functions. And there's reasons for doing this, and I'll get into those shortly. Let's go ahead and find the explicit functions. Explicit functions are when you solve for the y. So let's go ahead and get this y by itself. I end up getting x squared plus 16. I'm going to divide by 16 on both sides. Y squared equals x squared plus 16 divided by 16. And then I'm going to square root both sides, so I end up with the function plus or minus, or the two functions, I should say. Together they aren't a function. They're actually a hyperbola. So plus or minus the square root of x squared plus 16 all over 4, because the square root of 16 is 4. If I sketch these two functions, this is really fast sketch. They would look something along these lines, where this one would be the y equals the square root of x squared plus 16 over 4, and this one would be y equals negative square root of x squared plus 16 all over 4. Taking those explicit functions onto this next screen, I'm going to go ahead and copy down what the explicit function was. It was plus or minus the square root of x squared plus 16 all over 4. What I'm going to show you is that if I was to solve this implicitly, I will end up with the same answer as if I'm going to take the derivative of the two explicit functions. I am going to start out by solving this implicitly. It is much easier to solve this with implicit differentiation than using the other differentiation. So solving this implicitly, I'm going to end up with 32y, and then I'm going to put dy over dx. Remember I said I was going to continue to use dy over dx? And that's because this wasn't an x. Minus 2x equals 0. Now I need to solve for dy over dx, so I'm going to add 2x to both sides. I get 32y dy over dx equals 2x. Divide by 32y on both sides. And my dy over dx is equal to, it would be x over 16y. So let's go ahead and take the derivative of the explicit functions and see if we end up with the same answer. This would end up, I would want to rewrite this as plus or minus 1/4 x squared plus 16 to the 1/2 power. This will allow me to go ahead and say that y prime equals, bring this out in front, plus or minus 1/8. Rewrite what's on the inside, x squared plus 16, lower it by 1, negative 1/2, times the derivative of what's on the inside, which is a 2x. So I took the derivative of the x squared plus 16. And now I'm going to go ahead and simplify this as being plus or minus, this would be 1/4. And I'll go ahead and extend this out because this is also on the bottom of the fraction. X squared plus 16. And I have an x on the top. So I'm going to actually erase one that's up here on top. Now, you guys are looking at this and saying these aren't the same. But they truly are the same. I'll show you why. If I go back to this explicit form before I took the derivative, I notice that it says 1/4 the square root of x squared plus 16. I'm going to solve for the x squared plus 16 part. So I'm going to multiply by plus or minus 4 on both sides, and I get plus or minus 4y on the left-hand side. So I'm going to replace this x squared plus 16 with a plus or minus 4y. So down here on the bottom, I now have 4 times plus or minus 4y, and I have x, and I have a plus or minus sign out front. This does give me the same answers. Okay, I still ended up with x over 16y for my dy over dx. So it's much easier to use implicit differentiation than trying to use that explicit form.